some other quick meta theorems that I think we already know. So the first meta theorem says that the following are equivalent. So gamma proving bottom is equivalent to gamma proving every well-formed formula, is equivalent to gamma proving B and not B for some well-formed formula B. And as you can imagine, this means that gamma is inconsistent, because we know we can't prove bottom. Bottom is false, right? For any state, bottom is false, so we shouldn't ever be able to prove bottom from any hypotheses. At the same time, we know that there are different well-formed formulas that contradict one another. In particular, B and not B cannot be, this statement cannot be true because B and not B are not true at the same time. So there are well-formed formula in which we can't prove, right? So this statement says that we can prove every well-formed formula, and that simply isn't true. At the same time, in particular, we can't prove this one. So this tells us that there's something wrong with our hypotheses, that they're inconsistent and they can't be true at the same time. This leads us to another well-known method of proof that you've asked about in class, and that is proof by contradiction. So this is also a meta theory, right, because it tells us another type of proof method. And here is what it looks like in our notation in logic, but it is exactly the same statement that you learned about in 1019, right? So it simply says to prove gamma implies A. So from the hypothesis gamma we can prove A. We can, instead of doing this directly, assume that A is false, so assume the conclusion we're trying to get to is false, and reach some kind of contradiction, right? So proving bottom is like getting a contradiction, and so using this proof method is the proof method of contradiction. Assume the opposite of A, the negation of A, and derive a contradiction. And you will see that we don't often apply this method directly, but we use proof by contradiction in our proof by resolution that we'll talk about in the next video. So just to summarize again, so when you're using the proof by contradiction, instead of proving A directly, we assume the negation of A, or assume that A is false, and derive a contradiction. So we essentially are proving the inconsistency if we assume that not A is true. Okay, so now we're going to be able to see how to apply both the deduction theorem and proof by contradiction in our proof by resolution method.